Hello Math 7 students, this is Utah Middle School Math Project 4.3e. We're going to be looking at proportional constants in markups and markdowns. You might remember the whole unit is called proportions and percents. So we are going to be tying in some proportions, meaning that proportional constant or the constant of proportionality as we deal with these percent problems. To get started, we have this warm-up. So please pause the recording to answer this question and continue the recording when you have your answer so we can check it together. Okay, and we're back, ready to go over this warm-up. Students in class, I did catch some of them. You need to make sure that you're paying attention to what the question is asking. Joanne Fabric has soft minky fabric on sale for 25% off the original price, and the original price is $12. What is the discount? I did not ask, as I have in all of the others past, what the new price is. I asked instead, what is the discount, meaning how much are we saving? So we should handle this problem differently. What I think happened is you guys just assumed I was going to be asking like I always have. So you went 100% minus 25% is equal to 75%. However, I'm asking instead just what is the discount. When I do this, this is going to give me the new amount, or what I'm paying after the discount. When I'm asking for the discount itself, we're just going to calculate with the 25%. So that would be 25% of the original price, which is 12, and 0.25 times 12, or 1/4 of 12, is equal to $3. The discount is $3. So I did catch some of you on that one, not because you don't understand what's going on and how to handle these percents, but just because you weren't paying close enough attention to what the question was asking. So it is really important today that you are paying attention to what the question is asking. We're going to be looking at a bunch of different situations where I give you different pieces of information and you need to understand what to do with that information. So let's get started on 4.3e, proportional constants in markups and markdowns. What it says here says find the missing price for each. So in the first couple examples, actually, it gives us the original price. It tells us what's happening. We're increasing by 40%, or later on, maybe we're decreasing by 5%. Before we answer the question, notice that there is this baby step. Write the equation that's going to help us to calculate the final price that it's asking. After we do that, we'll look at that equation and then we'll come back and look for what is that constant proportionality. So let's do this first one together. The question is giving us the original amount of $16.20, and it says we're increasing it by 40%. Just a quick discussion at your tables. Why would we have a price and then increase that price by 40%? Just a quick check-in. Let's make this real life. What do you think is happening there? Check in with your groups. Okay, now come back and share with me, what are some reasons why a price might increase 40%? Gideon. That would be an insane amount of taxes, but sometimes we see increases because of taxes. Carter. Short supply. So something is in very high demand, so they increase the price 40%. Sophie. Exactly, and that's what I think of this as, is profit. This is the company that is paying $16.20, but the company wants to make profit, so they're increasing it 40% so that they can make money off of it. That's the way that I think of that. Any other ideas? Okay, for this one, because of the amount increasing, I think profit is probably more realistic than an insane amount of tax, but as long as you're thinking about why something might be increasing 40%, you are on the right track. So what is the equation to calculate the final price? This is very, very similar to what we did in our last lesson. So if it's increasing by 40%, we understand that that is 100% plus 40%. That's what it means when we increase 40%. That is 140%. Now, of course, we don't calculate with that percent. We change that to the decimal 1.4. And with all of that, there we go. With all of that squeezed into that space there, I now have space. What is the equation to calculate the final price? Well, the equation is going to be 1.4, or 140% of our original price, which is $16.20. Notice this is not an equation yet. In order for it to be an equation, it has to be equal to something. Do we know the final price? No. So what are we going to use? A variable, n, the variable n. F for final price, n for new price, whatever you decide. You can even go with the old-fashioned x if you wanted to. I like n. That's what we used in our last video, so let's keep it consistent. It's equal to n, our new price. So this is the equation that we're going to use to calculate what is that final price. Notice n is already by itself, right? So since n is already by itself, all we have to do is this calculation. You should have typed it into your calculators. If you have not, please do so now. 1.4 times 16.2. Notice I'm lazy and I'm dropping the decimals at the end, the 0 at the end, and the 0 at the end here. The calculator doesn't need them. Gideon, what did you get? 22.68, is that what you said? Okay, 22.68. So what is that final price? The company, if we're thinking profit, the company is going to need to sell it for $22.68. Next question. What is the proportional constant? I'm going to let you guys discuss that for just a second. I'm going to pause the recording while I take care of a few things. What do you think we're asking when we're saying, what in the world is a proportional constant? This doesn't look like a proportional relationship, right? So what am I talking about here? See if you can figure it out. I'm going to pause the recording. Okay, what are your thoughts? What do you think we are meaning by what is a proportional constant? Carter? Yeah, it is, because that's what proportion or constant proportionality is, right? It's the number that we multiply by. So the question is, what is that number that we're multiplying by? Is it the 1.4 or is it the 16.2? Any thoughts? Davin, what do you think? It is the 1.4. Why would it be the 1.4? Yeah, so this right here, the proportional constant is that 1.4, and here's the reason why. No matter what the situation is, again, let's go back to a company trying to make 40% profit, right? That company is always going to want to make 40% profit. Whether the price is $16.20 or $75, they're always going to want to make that 40% profit. So the original price could change, right? As supply goes down or demand goes up, or any one of those things could influence the original price, or maybe it's a completely different product now. The original price could change, but this company is always going to want to make that 40% profit. So the proportional constant is 1.4. Okay. I just want to make that connection to our previous unit. So you're going to see that being asked again and again, and it's going to start looking kind of interesting. It might be a little bit more recognizable in the future. So just keep that in mind. Let's move on to the next one. I think this one is probably worth doing together only because we have this weird thing here. Let's talk about that. The original price this time is $1,050. The increase is 0.5%. Let's first make it real. What do you think could possibly have an increase of 0.5%? Why would it be increasing? Especially here, this was a huge increase. We thought maybe profit. What real life situation would be an increase of 0.5%? Talk with your groups first. Real quick check-in. Get some ideas from each other. Okay, and now come back to me. What do you think? What might be causing a 0.5% increase? Joshua? I would say probably interest. Yeah, I think interest is probably a good one. Any other thoughts? Sophie? Taxes, I wish taxes were that low. Usually taxes are going to be quite a bit higher. Unfortunately, taxes are always higher. Interest that you gain is always going to be lower. But maybe in a certain country, maybe that would be the tax bracket. It would be a low percent like that. Yeah. And I especially like this being thought of as interest because we're probably investing $1,050 in something into a savings account, earning that much interest. So let's do this problem together. Just like always, we're still going to have 100%. It is increasing, so that means I'm going to be adding, and I'm adding just 0.5%. Be careful when you do this addition. 100% plus 0.5% is 100.5%. And don't make an error here. What is that decimal that we're going to be using to calculate then? What decimal am I going to use, Gideon? Yeah, 1.005. Exactly right. Okay, let's write our equation then. We are going to be looking at 1.005 or 100.5% of the original, understanding that when I'm saying that, I understand that of means we're multiplying. So we're multiplying this by the original amount 1050. This isn't an equation yet. We need to make it an equation. It is equal to the unknown, the thing that we are trying to find out. So it's equal to n, the new price or the final price. Now, n is already by itself. Now we just need to do the calculation. What is 1.005 multiplied by 1015? Again, I have not done this. I'm waiting for you guys to do that calculation for me. Cambria? Sounds good to me. You guys get the same thing? Yeah. So what is that final price? $1,055.25. What is that proportional constant? What is the number that we're going to be multiplying by? Again, the interest rate probably isn't going to change. If we're thinking of this as investing money, the interest rate probably isn't going to change. What could change is how much money I have to invest, right? That is the part that could change. So this is the number that we're multiplying by. The proportional constant is 1.005. Okay, the next two, I bet you can practice. Oh, maybe just the next one. Practice with C. This is the first time we're seeing it, but it's a decrease. You guys know how to handle those decrease ones. D is something new, so we are going to talk about D together. I'm going to pause the recording and let students work on C. Maybe give D a try on their own, and then we'll come back together and go C and D together. Pause the recording, get those done. Ready, set, go. All right, let's check our work. This time it's decreasing 5%, so that means 100% decreasing 5%. That's going to be 95%. Real life situation, why might something decrease 5%? Any thoughts? What do you think, Liv? Losing interest, yeah? What else? Gideon? Yeah. Yeah, one of those, everything's on sale. It's only on sale for 5% off, but everything's on sale. That kind of a situation, a coupon or something. So we have 100% minus 5% is equal to 95%. We're going to be calculating with the decimal 0.95. What is that equation? That's 95% of the original amount. The original amount is 1980. And to make it an equation, that is going to be equal to n, our new or our final price. And what did you get when you simplified this and did that calculation, Dylan? 18.81? Sounds good to me. You guys get the same thing? So the final price here is $18.81. Tied into proportions. What is that constant of proportionality? LaRoya? 0.08. What did we multiply by? We took that original price, 1980, and what did we multiply it by? I think so. So 100% minus 5% is just 95%. So I think that's probably where your mistake came from. So the proportional constant would be 0.95. D. We've talked about these kinds of problems in the past. This is also where we've struggled. Do I know the original price? No. I do not know the original price. Do I know the final price? Yeah. So what is my variable going to be? Am I still going to use n, the final price, as the variable? No. Now, don't use O. O is a terrible variable. I know it means original, but don't use O. That looks like a 0. So maybe instead, G for the OG price. Maybe X, just the classic variable. We don't know what the original price is, but I do know that if it's decreasing by 85%, that's 100%. Oh, is this the one that you were looking at, Lorea? Yeah, I see. 100% minus 85% is equal to 15%. So what am I going to be using to calculate? The decimal 0.15. What does this mean? Well, it still is 15% of the original. Do I know what the original price is? No. So I multiply it by my variable x. When I do that, I know I'm going to get the new or the final price. What is that new or final price? We know it this time. That's $12.99. This is our equation. Notice there was a difference in words here. C, it was, what is the equation to calculate the final price? D, I'm asking, what is the equation that we need to solve in order to calculate the original price? But please notice, nothing else changed in that whole way that we set up the problem, right? Everything is still the same. Maybe the parts that are different are we don't know the original, but we know the new price, but the format of the equation is exactly the same. We need to solve this, and that's the hint that it gave us. We need to solve this in order to actually know what that original price is. But I can see that x is being multiplied by 0.15. So I'm going to undo multiplication with division. And whatever I do to one side, I do it to the other side. Yes, Carter. You could use a proportion equation. Yeah. Let's focus on just this version of the problem first, because that proportion equation, it works, but we have another lesson on that one. Okay. Good thought though. And what do you get when you do $12.99 divided by 0.15? You guys have your calculators. Tell me what you get. Cambria? $86.6. Or in other words, what was that original price? $86.60. Exactly. Does that seem right? It decreased by 85%. So does it make sense that if it was really expensive, it would then be really cheap to the final price of $12.99? Yeah. Okay, and what is that proportional constant? What is the number that we multiplied by? Now it looks a lot more familiar, right? It looks a lot like what we saw in our proportions where we have x multiplied by something. That proportional constant was 0.15. Okay, with that in mind, I want you to practice E and F, please. Two different types of problems. Just go through those same processes. We're going to pause the recording again, give students a chance to work on these, and we'll come back together to go over them. Pause the recording now as you work on them yourself. Okay, we really started seeing some interesting numbers here. An increase of 180%. I don't know what the original price is, so when I don't know that original price, it looks like I'm going to be using probably a variable x. But I know that I'm going to start at 100%. It's going to increase 180%. That's going to give me 280%. We don't see that very often. That means I'm going to be calculating with the decimal 2.8 or 2.80. So what am I doing? That's 280% of the original, or 2.8 times the original price x, which we do not know, but it does give us the new, or the final price, of 81.2. Then we are going to solve this equation where we divide each side by that 2.8. I have my process down. I do not have my calculations memorized, so help me out with this. 81.2 divided by 2.8. What did you get when you did that calculation? Thank you, Carter. 29 even? Okay. So what is that original price? The original price would have been $29. What is that proportional constant? What did we multiply the x by? 2.8. Okay, and F, the original price. This time we know the original price, and this time it's the final price that we don't know. So the final price is what's going to be the variable. I'm going to go back to N for that. An increase of 150%, that means 100%. Plus 150% is equal to 250%. I will be calculating with 2.5. What is that equation? 2.5 times, I do know the original amount this time, so multiply that by 55. And it gives me, and the new thing that I'm trying to find. Again, notice, here it said equation that we have to solve in order to calculate the original price. Here it's the equation that we just have to calculate. It's already solved and it's already by itself. And 2.5 times 55 is equal to, thank you, Trace. Sounds good to me. You guys all get the same thing? So what is that final price? $137.50. What is the proportional constant? What are we multiplying by? 2.5. Okay, you guys are doing great. Let's take a look at G through J. Notice these are multi-step problems. Fun fact, these multi-step problems, if you utilize this system, they can be done in one step. Okay, let's go over the first one together. Notice on each one of these, I do give you the original price. Okay, so the original price is $100 and it decreases by 20%. So maybe it goes on sale or something. And then for some reason, it increases by 20%. What's happening? So maybe there are some stories that we have in a future lesson that will tell you why maybe it's doing these things. But if it's decreasing, just focus on this. If it's decreasing, what's happening? That's 100% minus 20. And that is equal to 80%, right? Don't worry about this part just yet. Let's just stop here for just a minute. What would I do with that information? What are the steps that I would take? I don't calculate with 80%, right? I change that to 0.8, but what would I do here? Talk with your groups because there should be hands here. How do I do this? Don't worry about the rest of this right now. Just focus on this. If this were the problem, what would you do? Okay, now come back to me. What would you do, Carter? Yeah, we multiply 100 by 0.8. And that is going to give me the new price, right? But notice what it says next. We're not actually done with this problem. Then, after we do that, then we increase it by 20%. What does that mean? That means we're back to it. I'm just going to switch colors here. That's 100% plus 20%, which is equal to 120%. That means I'm going to be calculating with 1.2. What do I do with that? Again, just like here, what did I do with the 0.8? I took that 0.8 and I multiplied it by 100, right? Only now I'm going to take that 1.2 and what am I going to multiply that 1.2 by? Quick discussion with your groups. See if you can figure it out. Am I going all the way back to that original price? No, what am I going to? Devin, you had your hand raised a little bit ago. Not even the 80, but the 80% of 100, this whole entire thing, right? Because this right here, this is that temporary new price. So all of that right here, let me see if that is what we're going to be multiplying by, right? Because this was the discount, but now we've got that discount that we are then increasing again. So parentheses are helpful here. We did this first. After we did that, that gave us our discounted price, but then we're increasing the price again, multiplying that price by the 1.2. When I do that, that finally gives me the new, complete, final price. I'll use F here for the final price. There's our equation. So let's calculate this. What is 100 times 0.8? And what is 80 multiplied by 1.2? Talk with your groups. Do those calculations. Raise your hand when you know. Thank you. Oren, what'd you get? 96. Isn't that interesting? How many of you guys were expecting it to go back to 100? Here's why. Am I comparing this 120% to the original? No, it's compared to the discounted amount. That's obviously going to be less. So 120% of 80 is different than decreasing and then increasing back up again. Remember with percents, we're always comparing to something. Always. And here, we're comparing, that 120% is compared to a much lower amount than we originally started with. So 96 is equal to F, that final price. So the final price is $96. If they decrease it by 20% and then increase it back 20%, we are still going to be getting a deal. How does this compare with the original price? It's lower. We weren't probably anticipating that, but it is lower than the original. I'm going to try and write this out. So when I'm decreasing at 20%, that's compared to original. However, in the very next step, when I'm increasing at 20%, I'm increasing the 20% as it compares to the lower sell price, not to the original. That's why we're seeing that interesting behavior there, that it's lower than the original. It is not asking for it, but I want us to follow that same sort of procedure. What is the proportional constant? What are we multiplying by? And that gets us into some fun mathematical properties, the associative property of multiplication. We did this first, but the associative property of multiplication says it's okay to regroup them and do this calculation first instead. Do that. What is 1.2 times 0.8? Type that into your calculators. What is 1.2 times 0.8? What'd you get, Cambria? 0.96. So if I do this calculation first, that is 0.96. What is our constant of proportionality? 0.96. And that explains why it got lower, right? Because 0.96 is lower than that 100%. Let's try it again. Again, we can see it's increasing by 15%, decreasing by 15%. Do you think we're going to land back at 80? You're older and wiser now, right? You saw that last problem. You saw it didn't work out. What do you think? Is it going to end up higher or lower? Here it was lower than the original. Is it going to be higher or lower this time? Talk with your groups. Make your prediction. And then let's go over this. Okay, let's do this together. If it increases by 15%, that's going to be 100%, plus 15% is equal to 115%. That is 1.15. Don't go any further. Let's just stop there for a second. What would I do with just this information alone? I would go 1.15 multiplied by the original amount of 80. And that is going to give me the new price, right? I'm just going to take that, put it in parentheses. That's going to give me that new price. But then after we increase the price 15%, then I'll decrease it 15%. That's going to be 100%. Decreasing, so minus 15% is equal to now 85%. And again, if this were the only thing that I would do, I would take that 0.85 and I would multiply the 0.85 by the original price. Only what is the sort of new original price? It's this amount here. So I'm taking that 0.85, multiplying it by this guy right here, the 1.15 times 0.8. And that is going to give me the new or the final price. Sorry, I made a mistake here. Not 0.80. 0.8. No. $80. Goodness sakes. $80. I'm sorry for that. Okay. Find that final price. And is it lower or is it higher? You've made your predictions. Does it match? Whenever you have that calculation, let me know. Okay. We'll wait for a few more. Don't rely on someone else to do your work for you. You type it into your calculator. Thank you. What did you get, Joshua? 78.4? 78.2. Thank you. So what is the final price? That would be $78.20. So higher or lower? That's lower than the original. Is this a good business plan? The item costs $80 and you say, I want to make some profit, so I'm going to increase it by 15%, right? But then you say, I want to give them a deal. I'll decrease it by 15%. Are you even going to make back the money that you paid? No, not a good business model, right? So again, how does this compare with the original? This is also lower than the original. Let's make sense of why. Again, we started by increasing the price 20%. But when I increased the price 20%, I compared it to the original. And now that amount is higher. It's much higher than it was before because I just increased it. So now when I'm decreasing it, sorry, I did not mean to write 20%. I was just looking at what I wrote over here. Now when I'm decreasing it 15% again, we're like, oh, well, we're just backing it off the same 15%, only now this 15% is compared to the higher amount. Which means that 15% is a bigger part of the whole because it's compared to a greater amount. Okay, let's finish up these last two. Okay, and now the original price is $40, decreased by 25%. This is what I was talking about earlier. Why is it decreasing 25%? Because the product is on sale. But then it increases 6% because we have to pay sales tax. So again, we can do this in 2 steps, but really truly, if we take advantage of writing these equations out, we can see that this can be completed in just one single step. So if it's decreasing by 25%, that's 100%. Minus 25% is equal to 75%, so I will be calculating with 0.75. That would be 0.75 times the original amount, which is $40. That's our first step. But with that first step, we then are taking that amount that we get there, and we have to increase it 6%. So 100% plus 6% is equal to 106%, or the decimal 1.06. So again, this is the amount that I'm going to be paying when the product is on sale, but because after that I still have to pay taxes, then we're taking that amount and multiplying it by 1.06. That is going to give me the new final price. So when I simplify this calculation, 0.75 times 40, which is then multiplied by 1.06, I end up with 31.8. Or in other words, the final price is $31.80. Once again, you can, if you choose to, you can complete this in one step, doing this multiplication first. 1.06 times 0.75 is the new constant proportionality, 0.795, or 79.5% of the original amount. Or you can just do it as we wrote out that problem. Next one, the original price is $150. We are decreasing this by 30% because the item is on sale. So 100% minus 30% is equal to 75%. I'll be using the decimal 0.7 to calculate. After that, it's decreased even more. So after it's on sale, now we get to use a coupon. That's going to be 100% minus 10% is equal to 90%. Calculating with the decimal 0.9, but we've got to do this in the right order. So first, we know that this is on sale for 30% off. So 0.7 multiplied by 150. So we walk into the store and we see it's 30% off and we see that it's listed at this price. But then we use our coupon at the register. So after this has already been done, once that part has been taken care of, we then go up to the register and we say, now I would like to use this 10% off coupon. So now I'm only paying 90% of this as the original price. Even though it's not the original, that's kind of the original once we walk into the store. All of this is equal to that new or that final price. So I'm going to do that calculation. And I get that that new final price is equal to 94.5, or in other words, 94.50. Now, sometimes students might make the mistake of saying, well, it's 30% off, so that's minus 30. That gives us 70%. And then we take away another 10%, so that's going to be 60%. But here's why that doesn't work. Once again, this 90% is based on a different total amount than this discount is. This discount is based on $150. This 90% or that 10% discount is based on not 150, but 100 or 70% of 150. So one way to kind of test that out and confirm is do this. Calculate this amount. What is that 0.9 times 0.7? And you will see that that is actually 0.63 times 150. So if you were going to make that mistake and say, okay, 30%, 100% minus 30% is 70%, minus 10 more percent is 60%, you would be calculating incorrectly with the decimal 0.6, when really truly it would be 0.63. So it's really important that you understand that these are two separate steps. We can do them in one step, but even as I do them in one step, one single equation, I'm still taking it piece by piece. So make sure you keep that in mind as you work on your homework. Your homework is the 4.3e homework section. You're going to see the same types of problems that you saw in class. So give that a try. That's it for today. Thanks for watching, and we'll see you next time.